So I knew last section that cross products are coming up soon, but I thought it was going to be in that lesson, not the next lesson. So here's lesson 2.7, solving proportions using cross products. Just like we talked about back in 2.6, a cross product is just if you have two proportions, so A over B times C over D. One of the easiest ways to solve this is to multiply across the diagonals. So A times D will then be equal to B times C. And that's a good way to help solve proportions. So let's solve a few proportions. Let's do our cross product. So 8 times 15 is going to be 120 equals 6x. Well, now we can divide both sides by 6. And we're going to come out with an x equals 20. That makes it pretty quick to actually do this math. It also lets you do it if you have x's in multiple spots so that you can later combine your x's together. So 4 times x minus 3 is just 4 times x minus 3. 8 times x is just 8x. We will have to distribute that 4 into both spots, so we'll have a 4x minus 12 equals 8x. We can now get all of our x's onto the same side. I'll change that to a plus negative 12 minus 4x. So we'll have a negative 12 equals 4x. We can divide both sides by 4, and we'll be left with x has to equal negative 3. So that's how you can just sort of start tackling cross products some. So here's a word problem. Each day, the seals at an aquarium are fed 8 pounds of food each for every 100 pounds of their body weight. A seal at the aquarium weighs 280 pounds. How much food should that seal be fed per day? Well, we know that if the seal weighs 100 pounds, they're going to be fed 8 pounds of food. Well, now we know that this seal is 280 pounds, so how much food does it need? Let's solve. So 100 times x gives us 100x. 8 times 280 comes out to 2,240. We can now divide both sides by 100, and that's going to come out to x equals about 22.4 pounds of food. I'll toss my label on there too. So that's another way that you can use proportions. This is actually a piece that, especially if you're in management at some point, if you are running your own company, you'll have to be doing this by hand. If you're working for another company, you'll probably have a computer that's programmed to help you figure this out. Either way, this is something that's used in the real world quite a bit. Another thing that ends up being used in the real world quite a bit are scale drawings, scale models, and just scales. So if you see a map of the world, or of a state, or of your city, it's helpful to be able to see where stuff is, but if you look generally in the lower left-hand corner, there's going to be a scale that shows like this distance is equal to 1 mile. And so if you just go and take that little distance, you can now measure the distance between places on that map. What that means is the map is actually a scale drawing. It's taken the whole city and reduced it proportionally down to scale. So if it was originally 100 feet long, let's say 100 feet long, well, we'll just leave it at 100 feet, and we're going to reduce it by a size of 1/5, that's then going to mean that our new answer at 20 feet, every 20 feet on the scale drawing is going to represent 100 feet. So it's just a way of being able to shrink things down so you can still see how big or what the size comparisons are within this drawing. A scale model is the same sort of thing, except it's now 3-dimensional. Scale models are generally not actually physically built that much anymore. They're all just generated on a computer. Or if they're actually built, they'll be 3D printed, which is kind of awesome. So that's another application of proportions. You can still solve them the same way, but just wanted to at least show you why this is something that's more practical in our world today. So that's going to be it for this lesson. Good luck, and as always, let me know if you have any questions.